method of determining the voltage regulation of the alternator. We know that in the case of synchronous reactance method, the finding the voltage regulation, we are converting all EMFs, all MMFs into EMFs. EMF method of finding the voltage relation of the alternator. We know that in the synchronous method, synchronous impedance method, or in the EMF method, finding the voltage regulation, we linearly converted all MMFs into EMFs. But in the case of the MF method, MF method of finding the voltage relation of the alternator. We know that in the case of a synchronous reactance method or the EMF method for finding out the voltage regulation, we are converting all MMF into EMFs. We know that there are three causes for changing the voltage from generated voltage to the terminal voltage V, because of IRA drop, because of leakage reactor stop, and the third one is the armature reaction. In the case of synchronous reactance method or EMF method, there is an armature reaction part that is also converted into one of the EMF in the form of IA into XA. That is, we are assuming fictitious reactance. In the case of MF method, finding the voltage regulation is considered exactly opposite to synchronous impedance method. In there, there is a IRA drop that is considered as it is. In the case of synchronous reactance method, IAXL drop that is considered as it is. The armature reaction is converted into its equivalent EMF. Okay, but in the case of the voltage regulation to using the MF method, there are the one drop, that is IXL drop, is converted into its equivalent, the MMF or magnetomotive force. That is, actually there is an armature reaction is taken as it is, whereas the IXL drop is considered as one more armature reaction drop. The same thing is written here, that is, it assumes that armature leakage reactance to be additional armature the reaction. In other words, it is assumed that the change in the terminal voltage, that is the potential difference on the load, is due to entirely by the armature reaction, that is we are considering, and also due to the ohmic resistance drop, which is in most cases is negligible. Sometimes Ra is very small, that IRA drop is neglected. Means the whatever there is a leakage reactance drop, IXL drop, it is a drop that is converted into equivalent the armature reaction. There is a armature reaction. Okay. Then the field current required to produce the voltage E, that is our object is to find out the value of the generated voltage E. The generated voltage E, which is the vector sum of, that is, you have to find out the value of E so that you can find out the regulation, that is E minus V divided by V. To find out E, the one thing is required is what is the field current required to generate V plus IRA cos phi, or in precisely if you are talking, it is V plus IRA, that is a vector sum of V plus IRA corresponding to V plus IRA cos phi. What is the field current required? That is considered as IF1. That is, we want to find out what is the field current required to generate value of E. This E is nothing but it is V plus IRA, that is a vector sum, plus IXL plus armature reaction. The first thing what I am considering here is what is the field current required for V plus IRA cos phi. That is what I am calling is IF1. That is a field current required to generate V plus IRA cos phi under no load condition. Then the second current, that is a field current required, that is IF2, which is corresponding to overcoming the armature reaction. It is a comparison of leakage reactance drop as well as actual armature reaction. Okay, there are two field current you have to calculate. That is how we are determining these two field current, that we will see that. That is the field ampere turns or the field current required to produce V, or if RA is given, then it is V plus IRA cos phi. Corresponding to V, if RA is not given, or if RA is given, corresponding to V plus IRA cos phi, on the load, what is the current required? That is the field current required, that you will find out. That is from the open circuit characteristics, what is the field current required to generate V plus IRA cos phi under no load condition? That is IF1. Then the second one is the field ampere current ampere turn required to overcome the demagnetizing effect of armature reaction on full load. That is, one is the field current required corresponding to V plus IRA cos phi. The another one is the field current required to overcome the armature reaction. This is IF1 and this is IF2. This value is found from the short circuit test. The first one we are getting from the short circuit open circuit characteristics, and the second IF2 we are getting from the short circuit characteristics. That is corresponding to V plus IRA cos phi, that you have to mark on the open circuit characteristics. We are getting IF1. Corresponding to full load current, you have to project on the short circuit characteristics. Then you have to find out what is the corresponding value of the field current, that is IF2. That is the same thing is given, that is OA, this is a field ampere turns or a field current to produce a normal voltage V or V plus IRA cos phi, that is IF1. What is OA? I will tell you with the help of the graph. Then OB is the field current required to neutralize the armature reaction. OB is the field current required to neutralize the armature reaction. Then if you are adding vectorially OA and OB, then you are getting the total field, that is IF. Corresponding to IF, you have to find out the value of E. Then the total field current AT required are the sum of AO and OB. That is, I will show you what is the AO and OB in the vector diagram. AO is the field current required corresponding to V plus IRA cos phi under no load condition. The OB is the field current required to circulate full load current under short circuit condition. Okay, then the total ampere turns is AO plus OB. The AO can be found from OCC, I told you. OB can be determined from the short circuit characteristics. Okay, the procedure is very simple here. How to find out AO and BO? That is, first, with the available data of open circuit characteristics, you have to draw the open circuit characteristics. Then using the data of the short circuit characteristics, you have to draw the short circuit characteristics. The first thing is, what you have to do is, you have to find out what is the value of V plus IRA cos phi. V is the terminal voltage, it is given, that is, you have to see that V should be per phase value. IA is the rated current, RA is the resistance of the armature caused by the load power factor. Then if the RA is not given, you have to take this whole term as 0 corresponding to VF only you have to take. That is, the corresponding to V. In case if the RA is given corresponding to V plus IRA cos phi, you have to mark on the open circuit characteristics. That is, I am marking here. That is V plus IRA cos phi if the RA is given. If the RA is not given corresponding to V, you have to mark on the open circuit characteristics. The corresponding value of the field current you have to find out, that gives OA. That is, OA is nothing but that is IF1. That is the field current required to generate voltage V plus IR across under no load condition. Then you have to calculate the rated current IA from the short circuit characteristics corresponding to IA rated current. You have to project on the short circuit current on the short circuit characteristics. I have got the IA rated here, that I am projecting on the short circuit characteristics. Then the corresponding value of the field current I am finding out, that is OB. This is OA and this is OB. The current here is IF2. That is, if you are adding IF1 and IF2, then what you are getting is total field current required to generate the total voltage E on the open circuit. Okay. The next step, first you have to measure OA. You have to measure with the scale here, then convert into the field scale of the x-axis. Similarly, you have to measure what is the OB in terms of centimeters, and you convert into its field current by multiplying the scale whatever you have taken on the x-axis. That is IF1 and IF2 we are getting. The same thing I am drawing here, that is how we are adding this factorially for different load conditions, how these IF1 and IF2 are added. Can look into here. MN is nothing but your IF1, that is field current required to V plus IR cos phi. That is this IF1. Then you have to drop a perpendicular here. Okay. Then lagging you have to take in the clockwise direction, whereas the leading vector should be taken as in the anti-clockwise. It is a lagging load, therefore IF2 you have to add lagging this by an angle of phi. Therefore I am adding here the field current IF2, that is NP is nothing but your IF2. That is IF1 is corresponding to V plus IR cos phi. IF2 is corresponding to the short circuit current, which is corresponding to rated current. Then vector sum of these two, what I am getting is the total MP, that is IF. Corresponding to this IF, you have to find out the value of E, then you have to find out E minus V divided by V is the regulation of the alternator. Okay, this is how you have to find out the total field current. Okay. For leading load, once again the Mn is IF1 corresponding to V plus IR cos phi. Draw a perpendicular and you have to draw your vector here in the anti-clockwise direction, that is corresponding to the field current required to circulate full load current under short circuit condition. Then once again MP gives the total field current. In the case of leading load corresponding to IF, if you have to find out E, then E minus V divided by V gives the regulation of the alternator. Similarly, for unity power factor, if the load is unity, this is once again the field current required to generate V plus IR cos phi under no load condition. Here you have to add all along the perpendicular axis, that is IF2. Then the vector sum of Mn and Np, that gives the IF. This is how you have to find out the total field current for different load conditions, and corresponding to this the IF you have to find out E, then you are finding out the regulation of the alternator. Okay, exactly how we are doing that we will see now. That is Mn is nothing but OA, Np is nothing but OB, and total field current IF is nothing but Np. Okay, the same thing is written here. Then for different the power factors, for a different power factor, the total field current is fall on a locus of a semicircle, that I want to demonstrate here. For example, Mn is the field current required for generating V plus IR cos phi. The Np is the field current required to circulate full load current under short circuit condition. Then I am taking here lagging load. Then your resultant is Mp, it is for lagging load. Then I have getting the total, the field current IF here. Then taking Mp as a radius, radius, just I am drawing a semicircle. I am drawing a semicircle. Okay, that is a locus of a, sorry, from here I am drawing a locus of the semicircle. Then now I am changing over from lagging load to the unity power factor load. Therefore, we can look into carefully. This is NP, it is for power factor is changing from lagging to, it is unity power factor. NP I am added here, then ENP here, what I am getting here. Okay, next. Now you consider for leading power factor. Leading power factor. Then this is your P. Means NP is nothing but your the total, the field current, means it is falling on a semicircle. Okay, previously for unity power factor here, for lagging somewhere here, you are getting the total field current, means it is on the circle, on the semicircle what you are getting. Okay, otherwise it is a one method of finding out using the drawing the vector diagram. Otherwise you have to go for a formula for finding out IF by the triangle. That is, this equation is derived from this vector diagram itself. That is, the total field current or MP can be calculated as, if you know the IF1, IF2 and the power factor angle phi, then the total field current is IF1 square plus IF2 square plus or minus 2 IF1 IF2 sin phi. Here the plus sign you have to take it when the angle of lag or a lagging power factor, and minus sign you have to take when the power factor is the leading. Okay, the same thing is written here. Plus here you have to take for the lagging load, and minus you have to take as a leading load. For unity power factor, phi is become, for unity power factor cos phi is 90. For phi is unity power factor. The both are in phase. Therefore, phi is 0. Sin 0 is 0. Sin 0 is 0. Therefore, the second term is become a 0. Therefore, in the case of the unity power factor, the total field current what we are getting is IF1 square plus IF2 square. In the case of lagging and leading, you have to put the phase angle of the load, and plus sign you have to use for lag and minus for leading power factor. Okay. Then steps involved is, I told you, it is you have to find out V plus IR cos phi. Corresponding to V plus IR cos phi, you have to find out what is the value of IF1. From OCC you have to finding out IF1, that is, it is corresponding to V plus IR cos phi, not simply V plus IR, it is V plus IR cos phi. And the third step is, from short circuit characteristics you have to find out what is the IF2. Then from the MMF phasor diagram you have to find out what is the value of F, or you can make use of the formula. Then find out IF. Corresponding to IF, you have to project on the OCC and find the value of E, so that compute the voltage regulation. The voltage regulation can be calculated as E minus V divided by V into 100. Okay, this method gives the regulation lower than the actual one. Therefore, this method is called as optimistic method of finding out the voltage regulation. The procedure is very simple. Once again, I told you, that is, first you have to find out the value of Mn. Mn is nothing but IF1. Here it is a NP. Then you have to find out IF1. In the graph itself, you can put Mn here and NP with the angle of phi. So you can measure what is IF1 and IF2. Already your Mn and NP you are measured from the graph itself. That you are putting here. Then you are finding out the IF. Then you project this IF on this. The corresponding to this, you have to find out the what is the value of the E. Then E minus V, that gives the regulation. Then if you are confusing of drawing this vector diagram and projecting on this, what you have to do is, you have to make use of the formula of IF1 square plus IF2 square minus 2 plus or minus 2 IF1 IF2 sin phi, and